Okay, students, in this video we are looking to graph reciprocal functions. Y equals 1 over x, and this is what that graph looks like. It's basically two graphs in one, and the official name given to something like this graph here, it's called this one here, it's called a hyperbola. Hyperbola, that's the name of basically this graph here. And this function here, or this hyperbola, never really touches the x-axis or the y-axis. So we can say that in this case, there is a vertical asymptote. The vertical asymptote is, in this case, well, it's this one here. It's this line coming down the y-axis. We can say that x is equal to 0. That's the vertical asymptote. And we can also say that it has a horizontal asymptote of, so this is also a horizontal asymptote of y equals 0. So basically a shortcut is this. So whatever x cannot be, that's going to be your vertical asymptote. And if we had a value on the outside over here, which in this case we don't, we call that the horizontal asymptote. So there's two, so this one has two asymptotes, a vertical asymptote and a horizontal asymptote. In this case, we don't have any intercepts, so if I wanted to consider the asymptotes, there's two, but when I consider the x-intercept, well, there's no x-intercept. If I consider the y-intercept, there's no y-intercept. All right, so that's basically the main idea of a reciprocal function or a hyperbola. Let's look at another example where we can apply all this. And before we get to that, let's say we had g of x equals 6 over x. Determine the excluded value of x for this function. In other words, what could x be? In this case, x could be anything except x cannot equal to 0, because if x equal to 0 here, this will be undefined. Another example could be if I had f of x is equal to 2 over x minus 7. Determine what x could be here. And so we could say x could be everything except 7, because if I have 7 in the denominator, this would be 7 minus 7 is 0. 2 divided by 0 is undefined. So x cannot equal to 7 in this case. If I had, let's look at another problem. Let's call this p of x. P of x is equal to a negative 5 over 3x plus 4. What could x be? Or I guess determine the value of x that would make this undefined. Well, to make this undefined, I would have to set this equal to 0 and solve for x. So 3x equals negative 4. X equals negative 4 thirds. So in this case, x cannot equal to negative 4 thirds, because if it is equal to negative 4 thirds, this is undefined. All right, so just really quick, let's go back to the graphs. A couple things here. If I have g of x is equal to 1 over 2x minus 5 plus 2. All right, so this one, there's a couple things. The vertical asymptote is basically what makes this equal to 0. All right, so in this case, let's solve for x, and so I get 2x equals 5, x equals 5 over 2, or 2.5. All right, so let's keep that in mind, that the vertical asymptote is 2.5. Now let's consider the horizontal asymptote. In this case, it's just the number on the outside of 2. So the horizontal asymptote is 2. So if I'm going to graph this really quick, let's create a graph. All right, something like that. This is the x-axis, y-axis. And before I get to this, this has been shifted, well, to the right 5 units, and it's been shifted up 7. So now there is an x and there's a y-intercept. So to get basically to get the y-intercept, I have to set x to 0. So to find the y-intercept, set x to 0 and solve for x. So I have y equals 1 over 2 times 0 minus 5 plus 2. All right, so that is 0. And if I solve that there, y is going to be about 1.8. So 1.8 is the y-intercept. Now let's do the same thing for the x. So let's say I want to find the x-intercept. To find the x-intercept, we set y to 0. So 0 is equal to 1 over 2x minus 5 plus 2, and we solve for x, and here x, if you do all this right, move the negative 2 over to the left, multiply everything by 2x minus 5, x is about 2 and a quarter, 2.25. Okay, so we have the key features. So x, 1, 2, 3, 2.5. There's an x-intercept. Y equals 1.8, 1, right about there. So what does that graph look like? Well, let's consider this right here. We have a vertical asymptote at 2.5, and we have a horizontal asymptote at y equals 2. All right, so y equals 2. There's a horizontal asymptote like this, and there's also a vertical asymptote coming down at 2.5, give or take, right there. So that graph looks like this. Something like this. All right, and actually the 2 should be more up here. The 2 is up here, and this is the graph coming down. So that's what that graph looks like. The graph looks something like this and like that. All right, guys, I hope this makes sense. Please let me know if you have any questions. Let me know. Have a good day.